Hello and welcome to my shop, and thank you for coming and joining me here today, September 28th. It's near the end of September. Kind of a gray, cool day outside. I think that high today is 20 degrees here. No snow in the forecast. No snow in the forecast for a long time yet. Okay, so basically I've eliminated all the unreliable capacitors that are in the radio. There could be more bad capacitors, mica capacitors, but unless there's some proof or indication of trouble, there's really no use in going after them in any way. But this radio is full of resistors too, and testing them individually, not a very practical approach at all. What I'm going to do is I'm going to measure the voltages that should be appearing on each of the tube pins, because I have a chart here that shows those voltages. I think I do. And yeah, here it is here. So with this information, it's kind of a roundabout way of checking the resistors in the set. More than that, you're checking a little more than that, but so that's what I want to do. So to do that, we need this guy tipped up this way. And a little wobbly. Kind of wobbly. Let's try the outside of the big power transformer is round. Let's see if I can get this on. That's better. There we go. Okay. I don't think it's going to fall over now. And we're at the end of the speaker wire here. Okay. There we go. That's a big production right there. So I'm going to use this meter to do the measurements. Take the measurements to the chassis. That's how they were done. Now, yesterday something really odd happened in here. And some water spilled out of this radio, or so it certainly appeared. What happened was I was tipping the radio down, and I noticed water sitting on my bench. Now look at it. So that's not ordinary water. There was something in that water. That has appeared after the water has evaporated overnight. I still don't know. I don't know. I don't know what it could be. What could it possibly, what was holding water that length of time? Or did it come out of something totally unrelated to this, and I'm just clueless as to what really happened? I don't know. It's a mystery. Kind of wonder what that material is there, that white stuff. Anyway, let us continue here. So we will make the measurements over here. Nearly all of them, or all of them, will be positive voltage measurements. And this might be a little hard for me to look at. I think what I'll do is I'll go ahead and do the test because they're fiddly. And if I find something interesting, then I'll turn on the camera. And besides, it's already coffee break time. Well, I've changed my mind a bit. I think I'm going to drag you along for some of this process here. So first, we need this radio operating. Very good. And we certainly need to operate it at a proper line voltage here. Give it a chance to warm up reasonably. There we are. Oh, let me see if I can tune away that. Yeah, you just take this off. Yeah, that's good. There, we don't have to listen to it. So the radio is operating, and we don't have to listen to it. Fantastic. Okay, so you can see the first tube in the bottom left corner of the screen there. That's this tube here. And we're going to start with the plate, which would appear to be on the diagram, maybe this one. or maybe this one. Yeah, be careful I don't short something out here. Oh my gosh! Well, that was dumb. Always set your voltmeter first. So the voltmeter, we're expecting, I think, 80 volts here. Right, 80 volts. So let's set this to 150. So 80 is just beyond the middle here. Just beyond straight up. There we are, just beyond straight up. Perfect. Okay, the next reading would be on this one, really nothing. 1.5 volts. Not a very reliable reading on the cathode. It's not reliable because of the because I'm full of crap. That's no reason to think that. Let's see if we can get 1.5 volts. Ooh, does C stand for cathode? Don't they usually put a K there in the diagram? They put a C. Gives the current flow too. Notice the current flow for the cathode and the plate is the same. It's the same current. It's in behind this. It's the upper one in behind. Okay, so I think this is it here. Now we can go down. 15 volt scale. It came up and fell back. 1.5 volt scale. Should go full scale on this. Full scale and then drop back. I was on my way to saying something about the voltmeter would interfere with the reading. I think that's just fine. I don't think that's a problem. Okay, we're on to the next one. We're on to the next one here. 6L7. I haven't even looked to see if I have any of these. 6L7. So we'll go after the plate first. 235 volts on the plate, and the plate is I think it might be this one right here. Oh, it's all insulated very heavily. Now it's got insulation going right down over top of the pin. Oh, wait a minute, I'm not on the tube. Yeah, I'm looking. I'm not even looking at the tube, for crying out loud. It's because the way I shifted the diagram on the screen. Okay, so plate is going to be this one here, I believe. Oh, yeah. So on the 500 volt scale, at 235 volts would come up 235. Right where my finger is pointing. 235. Well, maybe that's not the right pin. So there we are. It says 250 on my meter. That was good. Didn't make sense though. What I just did not make a lot of sense. We had to be a little more certain here of what's going on. So this is a different terminal. This one we're reading on the 500 volt scale. That's exactly 100 volts. That's exactly what it should be. So I'll go back to the plate. The plate is reading. I don't understand what happened just now. Yeah, yes I do. I do understand it. Sure I do. So that's correct. That's just under 250, and it's supposed to be 235. That's just fine. Okay, that's great. Now we'll go on to the next tube. Next tube. I'm not measuring the AC voltages. I'm not worried about that. The AC voltage is for the heater. So on this next tube, 6A8, we have 235, 155, 100 defined. Those three voltages. And even a plus 3.5 if we care to. So starting with the 235 on the plate. That's right at the back here, and it's the upper at the back. But you get that. This one right here. So I'm on the 500 scale, so it should be basically straight up, or maybe not quite. Straight up. Ooh. And next door is 100 volts. That would be here. Right on 100. Could set my meter, calibrate my meter with it. 155 volts. 2 pins over inboard bottom. I think that's this one here. Okay, so on my meter that's 170, and on the chart again it's at 155, so that's good. We're running the radio a little low, 111, so all these voltages will go a little bit higher if with a little more input voltage to the radio. And now that's it for this one. We'll look for the 3.5 on the top. Got that? Top. That's this one here, I think. Looking for a tiny voltage here. So that's on the 15 volt scale. That's reading 3 volts. And it's supposed to be 3.5. It's just over 3 volts. Actually, you know what? It's very close to 3.5. Right on the money. Okay, that's great. Let's go to the next tube. We're doing great here. We're finding nothing wrong. So now we're on the output tube and the rectifier tube. So going to the, I may leave the rectifier tube alone. Going to the output tube down here in some darkness. Let's put a little more light on it. Okay, on this one we should find 225 and 235. You notice the screen grid, it actually has a higher voltage on it. 33 milliamps flowing through this tube. Of course we can't really, well, there's a way we can determine it, but I don't think we need to. 220, it's a hard thing to figure out the current going. I shouldn't say that, a hard thing. It's not the easiest thing in the world to measure the current in a tube. 225, I'll kind of take that back. Because you have, no, there's no cathode resistor in this. So it would be a little tricky, I think, to find out what the current actually is. 225, do the measurement, Jim. It's inboard bottom. Inboard bottom. That would be right here. Good thing I'm using a meter you can't damage. I would have blown it up a couple times. Okay, 235, and I'm getting basically 235, right on the money. And now right beside it, you know what? That might have been the this. Yeah, I think. No. Okay, hold on. Let me study again. Getting a little bit turned around. Plate, screen, plate. Yeah, plate, screen. A little bit higher. Let's just see. Is it a little bit higher? So we're just below the 250 mark on the meter, and we're a little below that here. Excellent. So the screen is slightly higher than the plate. Minus 16.5 volts on the grid. So we'll try the grid measurement, but this meter may draw the grid down. So it's a 5 volt scale. So I'll put on right on the 1.5 volt scale. Because the grid voltage is 16 volts, Jim. What are you doing? We'll put it on the 15 volt scale, and this should go all the way over and kind of bump the end. And then we can be happy. So we're on the -2. Yes. And yes, I'm just talking away to myself here. Here we go. So I want to get this right because you got the meter set so sensitive. So it's the inboard upward. Inboard upward. I think it's this one here. Yep. So you see just a touch low. It's on 14 here instead of going right off scale where it should go. But that could be due to the meter being hooked up here. Bringing it down. 14, 16. Can't complain about that. Very good. So I've gone through all the key voltages in the set and they've all come out correct. So this suggests to me there's really no concern about resistors or anything else really in the radio at this point. No reason to be concerned. Now it's time to turn attention to the alignment of the radio. And what we're going to want to do, first of all, I think this whole thing can be aligned from above. And I think it might need the bottom plate put on it to do it. But first I want to do a preliminary sort of alignment just to see if things are okay, and to practice where all the different connections are. So all the different adjustments are. Connections. What am I saying? Must be time for a break. Yeah, time for a break. Okay, so I'm just getting ready to do some alignment stuff, and I've decided now is a good time to loosen up this tuning here, which is so stiff. It's very, very hard to turn. So probably somewhere in there. Must be a gear-driven situation, and the gear is in behind this box. It can't be seen. How am I going to get oil in there? I'm not. So way down there. Way down there. Oh my gosh. Way down there. You know what? I think this is using the sliding plate friction technique here. So this big plate right here, this piece, I believe is simply pressed against a roller down below, probably on the inside. The inside of it is pressed against a roller. The roller is what you're turning with your hand. And the roller will turn this. When you get to the end and the capacitor locks up, something has to slip, or the turning stops, and there's always a risk the operator will advance it too hard at that point. Small risk, but so this technique, the rotor will just slide over top of this surface. It'll just skid on it. Now, what is really tight? I think it's this shaft that's really tight, and that's way down in there. Oh, you know what? There's actually teeth. Okay, so I'm right, but it's not a slider. There are teeth. My tip of my finger is feeling teeth on the inside of this. I think you can probably see them. Well, maybe not in the camera. So it's geared, which is great, and way down in there. Way down in there. Oh my gosh, it's better from the other side, I think. Okay, let's go to the other side and have a look. In the meantime, I was reading some operator instructions here for this radio, and they described the music speech control, and I'd have to read it again, but it seemed to me it said, turn it all the way clockwise for music, and then turn it back one stop, but it's just a rotating control here. One stop, turn it back one stop. Well, what's all this for? I don't get it. Sounds to me like they should have put a switch here, not a rotating control like that. But anyway, not to worry about that. Okay, so I think I can see where I can spray some stuff if I can get down in there. Oh my gosh, it's way down there. I need the extra long spray hose. Of course, when you tip the can upside down, not much comes out. But often in these things, it takes very little to do the job. Okay, I got there. Now can I squeeze the thing? I can't squeeze it. Oh, I did, but this is a stupid stupid arrangement, because when you push the top, you move the red pointer around. It's a dumb arrangement. I just sprayed something to nowhere. Okay, get some on there. Ooh, that's a lot. Look in there. What exactly is moving? Ooh, I'm gonna have to put a knob, or this thing got tougher. Wow, that didn't help at all. So there's another, like there could be a long shaft and bushing in here. Let's see what I can do here. And there's a lot of dust. Shoot that stuff. There, perfect. Got it right on the money. Not going to get much better. Oh, push on the capacitor. It'll help a bit here. Oh my gosh, that is just unbelievably tough. Like, it feels like it's getting tougher and tougher. It's easy now. Of course, you know, I'm just working this very small diameter shaft compared to, you know, putting a knob on there. Feels like it loosened up. Yes, it did. That's all it took. This will get a little looser as we go. Many more places can be tightened up here. My poor thumb. All the way to the limit. I'm just watching the capacitor back here reach its limit. Because this is geared, what happens when you get to the limit? I don't know. I'm not going to find out. I don't want to find out. Now, what about shooting a bit of oil up in here? Well, that feels great. That turns easy now. Yeah, that's got it. That's definitely got it. Okay, a few more things that have to be done though. Might as well do them all now with the capacitor. There are some, you know, contrary to what you might imagine, these plates are grounded, and the plates that don't move, these ones up here, these are the ones that are insulated from the radio. So how do you make these moving plates stay grounded? Because this stuff is moving. So you have sliding contacts, and they're right in here. There's a spring-loaded contact, and just a touch of WD-40 in here does two things. Cleans them up, like it'll improve the contact, and lubricates it. Oh, same thing back here. If these contacts are bad, then when you tune the radio, you get you know, the poor connection sound kind of stuff. And up in the front here is a set of ball bearings, which really WD-40 just isn't quite the right stuff for that. But can I get better oil in there? Okay, now this is liable to drip out on the way. Oh, yeah, right, drip out on the way. Yeah. Boom, I got it. It's a little clumsy, but I got it. So this should make the tuning a lot smoother and remove any bad contact spots. Not that I noticed any, but I didn't tune this radio much. It was so stiff. Go all the way. still kind of hard to do. Did I miss something? Harder than you would want, I think. Well, so the pointer is hooked up to the shaft of the capacitor straight through in here. There probably is no bearing at all coming forward to the pointer. There's nothing there to lubricate. It's probably just sitting in the air. So I think it's still this shaft. And what if we stuck a little oil right down the middle here? Probably not worth doing. Put the larger knob on here and this will actually turn quite easily. I think I beat this enough. I don't think I want to beat it up anymore. Okay, there we go. Now we got to get this loosened up anyway to do an alignment, because I have to tune here and tune there while I'm doing the alignment work. Very good. And what we're going to do before I do that alignment stuff, we wanted to do this experiment here with the bottom plate. So what I'm going to do is I'm going to put this on 1 million. That's 1 million there. And make sure this is on the broadcast band. Yes, it is. That's where it was all the time. Then we're going to hit it with a signal. Hit it with a signal from the signal generator here. Hit it. It's already hooked up. We're dialed in at 700, but we're doing this up at 1 million. Let's go for 1 million. See how accurate. So we're doing a number of things all at once here. We're checking accuracy of the radio, sensitivity, all kinds of stuff. Got to have the radio on though to do this. So plug the speaker back in. Okay. Back in there. Okay, volume down. Yes. Power on. What are the chances it's going to come right on? This is on 1 million. My signal generator is definitely on 1 million. Okay, we have to give it the full supply voltage. That was 87 volts and this radio was working. Can you hear that weird hum? It's right in the sweet spot of the volume control. I think I might disable this in the end. I don't think it's doing any valuable good. And when it's anywhere other than the extremes, you get that open circuit hum. Okay. Now, what frequency are we actually tuned to? Or is the radio actually tuning? So I'm going to change the signal generator frequency here from 1 million till we find it. I have a light signal coming up the radio. Oh, it is right on. It was right on. Oh, I've got external here. There we are. Now we're cooking. Okay, I'll set this to exactly 1 million. That would be right there. And I'm pretty sure this radio doesn't sound good. Does not sound so good. Too much signal? No, can't be too much signal. Tuning? It's amazing. It's right on. It's right on 1 million. I didn't even done anything to it alignment-wise. And now I just noticed something, for crying out loud. So this radio is designed to be aligned from above. Oh yeah? It's got this kind of... I have to get underneath the radio to do the 2IF transformers. And why do they look so different? This one's missing its cap. I don't think this comes off easy. Well, it's got the connection to the grid cap coming from up here. That's unusual. That's quite unusual. It usually comes from underneath, like this one. Like this too. You see the wire comes from underneath. Not right off the top like that. That's curious. Okay. Think, man. Why do you sound so distorted? Is it the tone control thing? No, that's not. Sounds distorted to me. Sounds buzzy. The sound, instead of sounding like a nice ooh, it sounds more like a bzzz. How's that for? That's my best attempt. Okay, what are we going to do here now? I'm going to put the bottom plate on and see what difference this makes. I need a more objective view of how loud this is. It's a completely contained speaker. I can't get at the voice coil connections there. We could do the AVC voltage thing again. And I'm going to have to tip this guy up on its side anyway. And I want to put the bottom plate on. I might as well have it up on its side. You know what? Stop for coffee. Too many things. Okay, so what's the deal here with the bottom plate? Well, they've made provisions for this plate to be on and alignment to still be done. So there are two adjustments up here. There's a little screw adjustment here, which adjusts the transformer inside this can, and another one over here. You see kind of a brass screw right there. You have to have access to those two guys. And there's quite a strong warning about doing this with the bottom plate on. I'm afraid I've been a little negligent at times doing this bottom plate thing. So what I do want to do though is I want to do a little experiment here. So I want to have the radio operating, know what its output is in some objective way, not just by listening to it, and then put the plate on and see what happens. Now maybe the radio will just tune right out, it'll be so obvious to us, but maybe not. In fact, if it is obvious, I don't need to do all that other stuff. I'm trying to convince myself that, yeah, this plate, bottom plate thing is critical. These big coils are sitting right here. You know, when the plate comes up, they're right up against them. Also, if you look at the drillings here, so it has two large drillings here which line up with these two guys. So you can have this plate on, push the tool through and get in there. It's got 4 more holes. Now if you look at them, you can see this one's dented in and this one's kind of scraped up. These two aren't. Now when you match this up, these two holes match with these. The other two holes, they're just in space. What are they there for? I don't know. I don't know. Whoops, missed. Maybe put the holes on the wrong side. Whoops, wrong side. Put them over here. I don't know. But that just, having these screws here, which are going into this plate, suggests again, there's a lot of sensitivity in this radio to this bottom plate being in place, and it's probably because of these big whopping coils sitting here. Whopping coils. So the problem with doing the objective thing, for instance, I'd like to monitor the AVC, is how can I do that with the bottom plate on? You can't get a wire out. So I got to find a sneaky way to sneak out a wire that's going to carry the, you know what, it's right up here. I want to pick up the voltage. It's right, I believe it's right here. What if I solder a wire here and send it out? That's what I'm going to do that. Send it out the top. Okay. So I'm looking at the circuit here, and I'm not sure monitoring the AVC is a good idea in this radio. So here's the volume control, and coming to it on the input side is the audio coming out of the radio. It's coming to it essentially full blast into the volume control, and then the volume control is selecting how much to send on to the amplifier. So the full blast signal is on this wire here. Now what if I hook up my voltmeter to here? I would get the DC what is used as a AVC voltage, I'd be able to read a DC voltage here, and that'd be ideal, except this wire goes right into one of the IF transformers, the second IF transformer. If I hook something up onto this wire, like a meter, there's a chance I'll disturb this. And I'm on my way to doing alignment. We don't want anything disturbed during the alignment process. So what I'm thinking is, well, what if I go on the other side, forget about trying to monitor the AVC DC voltage, and monitor the AC signal reaching here, just from here to the chassis. Would that work for me? Then I could turn the volume up and down and hear what's coming out of the speaker if I care to while I'm doing the work. But I can also have the volume rate down and still have maximum audio signal here. And I think this would be much less disturbing to the radio. After all, it's got this variable resistance going on in here. So clearly, as you turn the volume control, you don't whack out this transformer the way they have it arranged. So I think I'm going to try this. I don't know if it's going to work or not. Never done this. Almost always I'm using the AVC voltage to do alignment. That's a precarious thing in itself. The other alternative is you get on the speaker. Speakers all canned in. The connections aren't really easily available. So let's try. We'll go from here to the chassis and see what we get on a voltmeter. Okay, AC voltmeter. Okay, let's try and see what happens. So I guess this is an experiment on the way to an experiment. So what we want to find out is does hooking up this voltmeter, yes, this one over here, throw this radio off. Now, an AC measurement, these meters have much lower input impedance on them. In fact, there's a switch that has to be thrown up here to AC. There's a resistor in here, which is part of what gives this a very high impedance during DC measurements, but can't do it during AC. So this is set now for AC 15 volts. Volume is up just a wee bit. Power on. Speakers plugged in. Yes, yes. Yes, yes. Yeah, the signal generator still connected, still running at 1,000,000 hertz. Turn this down a little bit. My lights here, this light here, produces a fair bit of interfering noises when the supply voltage is too high. So I have to be a little careful about that. Okay, I want to give it the full Monty here. And listen to it. There's the sound. Now we'll tune it for right there. That's definitely the spot. Okay, we're going to hook up the voltmeter now and see if this disturbs the radio or not. In place I'm connecting it. Let's do it without the clip lead first. Input to the switch. So it does affect the radio. It seems to drain out some treble. It doesn't put anything on the meter over here. AC 1.5 volts. A tiny reading. So we're going to try another meter. I'm going to try this one here. This has a this is on AC. I don't know about this with AC. I haven't tried it at all. I think we can do this. Let's do this. We got a fairly low signal coming in right now because I can hear the background hiss. We're going to jack up the power from the signal generator. Hoo-ha! That raised it quite a bit. Let's see what we got coming into the volume control now. Watching over here, Mr. AC meter. Oh, that's excellent. Tiny difference. Tiny difference, but I don't think the volume is changing. I think some of the higher harmonics are being eliminated. This is like adding a capacitor. So if I clip this long wire on, good. So what I'm going to do is I'm going to solder this wire to that test point, and this wire goes through a little hole in the chassis and arrives at this clip lead up here. And that'll be my test point. I got to screw the whole base on. I'd like to be able to rip this wire out without taking the base off. It's in a bad spot there. Okay, so I'm going to get this set up here, and we should be able to make this work. Now, another alternative place to pick up a voltage is between the screen and the plate, plate and the cathode on the output tube. I don't like that approach because it involves high voltage. This doesn't. So I'm going to solder that right on there, and maybe, yeah. Okay. I'm going to stop for a minute here. Okay, I think I'm ready for the experiment now. Without the radio on, I'm going to practice putting this base on because I'd rather discover the craziness now than when the radio's operating. So I'm going to have the radio operating. I'm going to try to do exactly this right here. What's going on? I'm going to make sure it's not pinching some wires. I would hate to consider doing this with the radio operating. Now, it looks like the plate is bent a little bit here. Ooh, that's a lot. Straighten it up there. Wow, I didn't expect it to go that easy. Okay, here we go. Wow, you can't really see what's happening. Jeepers creepers. I don't think I can do this with it on live. I don't think I have the nerve to do this. There, I got it on. Well, that's where I want to get to. And then we got to put some screws in. It says, right in the instructions, it says make sure all screws are in. I think especially these two in particular. Well, I don't want to screw it in right now. So, but surely goodness, if there's going to be an effect, it's going to happen. I would think we would see it just from doing this. There's enough contact here. You know what's even easier? Put the plate on and pull it off. Hey. That's a lot easier. So okay, plate's on. We will tune the radio and everything with the plate on, like tune the front dial or whatever. Get a signal level, pull the plate off and see what happens to this. That's my plan. Okay, let's do it. So power on. Is there anything I'm not thinking of? No, I don't think so. Okay, full power. Full power. So already a difference? So the meter should be responding here. Well, what happened? I mean, the meter was all the way up to here. It's independent of the volume control. I think it's retuned. So now we're going to tune the signal generator because we can watch carefully what the frequency is. How far out did it go? That's how far it went. So clearly putting the, hey, those engineers weren't kidding. You know, put the bottom plate on, tune this radio up, and throw the plate on. That's going to be a bad result. So interestingly enough, before with the plate off, the radio was exactly on. The pointer right on 1,000,000 and the signal generator right on 1,000,000, but not no more. So what we're going to do is set this back to 1,000,000. And we're going to see, well, how far is that on the dial? It might just be the width of the pointer or something unimportant like that. Let's see. Come around, come around. Now, there's a parallax problem. Let's see if I can kind of get rid of most of it here. Step right up. Okay. So on the parallax front, there's quite a space from the glass to the pointer, so there's quite a bit of parallax there. Okay, just turn the volume way up. You can kind of ignore my voltmeter lead here. Okay, let's tune the radio. So you know what? Wow, you're way off. You're way off the parallax view, the non-parallax view, but I'm not. So using non-parallax view. Yeah, I said we don't have to listen to it. That's the voltage. Okay, let's see how much stuff I can knock down in my shop here doing this. So it's would appear to be dead on the money, wouldn't it? Hard, you know, the camera here, I can't be sure where the camera is. The parallax is quite great on this radio. Let me look again with my own eyeballs. So we're very close, but to be exactly on, would be about there. About 10 kilohertz out. That's not much. And the fact is, if we did this at other areas on the band, instead of 1,000,000 in the middle, we pick the high or the low, we might find it to be farther out. Well, we might. Let's find out. Let's find out. I'm going to dial this down to 600. Okay, I'm going to... So what the engineers do when they finish designing the radio, and they've tried their best to make the dial sweep as linear as possible. So an inch here is so many hertz, and an inch here is the same number of hertz. They can't do it. They can't do it. It's very difficult in the AM band. So if you look at it, you'll see that the high end of the band is crunched together and the low end is spread out. And what that really represents is the last ditch effort of the engineers to make the pointer correct. I'm just untangling some wire there. So do what you can electronically and mechanically and all that kind of stuff, and then in the very end you make the dial fit where the pointer is going for the frequency it's on. It's a cheat. It's cheating. Okay, done an awful lot of fiddling around here. I think one more thing we can do today before I quit is assess the IF frequency and maybe even adjust it a bit. The IF frequency in this radio is 470, I believe. Let's look and see what it says. It's written here somewhere. Mechanical. 460. 460 is the frequency. So we're gonna check that out. Oh, did you hear a little ding just now? Windows just told me there is no threats on my computer. Well, yeah, I'm the threat. Now, what we want to do is pushing the signal into the antenna still from the signal generator, but at the IF frequency of 460, and see what happens. This is a pretty strong signal I've got going here. So 460 with a little more volume. Listen to that buzz now. You know what it could be? Could be this wire. Could be this wire causing that buzz. Unfortunately, but that doesn't matter. I'm not going to throw us off in any way. 460, right? 460. Down we go. Can't go down. Go up to. You can't see a thing, can you? I'm standing right in front. See, I'm getting along. I've been in here for a while. It's almost time to go. 460. Listening. Wow, that was better than the regular radio signal, I think. Now I've changed bands on the signal generator, so the output level has changed. But let's watch this guy go, as I just crossed the tune point here. I got the volume up high. That's really what it is. Okay, we'll bring it up. Now we'll get that meter maxed up. There's the max point there. Right there. And what is the frequency? 460, dead on. Very good. That's really good. There's nothing to adjust. I'd be crazy to start adjusting this. For the IF. And I think I'm going to call it right there today. Tomorrow we'll deal with the RF side of things. The problem here is I've been unable to find any alignment instructions for this radio. Doing the IF alignment, if I went ahead and did it, is easy enough without instructions. But the rest of it, yeah, it's to wing it is a little risky. So that's it for today. Very good. I think this radio's working pretty good. The distortion we're hearing, we'll worry about that once I get the alignment straightened out. And chances are, if the IF is well aligned, the rest of it is well aligned. If it's coming right up on the frequency, like virtually dead on, maybe this radio is so well aligned there's nothing to do to it. Nothing worth doing to it. That I just take a risk fiddling around with the alignment. But there's only one way to know, really. There's two ways to know. One is to have enough information about the output signal level for a given input signal level. If you have that information, the amount of gain or something, you can make those measurements. You can find out. That's pretty tough to do. That's really tough to do. And I don't have that information for this radio. So, okay, that's it for today. Thanks a lot for watching, and tomorrow I will finish this radio off, I'm pretty sure. See ya.